So in last class, I was telling you about the spectral decomposition of the matrix, that any function can be written in that form of spectral decomposition. So let me today take an example to make that concept more clear. Okay, let us take an example. So I will take a matrix, suppose a sigma 3 matrix, which is equal to 1, 0 and 0 minus 1. Okay, suppose this is the matrix 1 0 and 0 minus 1. So I have already told you that, so just this is just to make you understand, because all of the functions of this diagonal matrix are very easy. For example, if I want to write sigma 3 to the power n, what it will become? It will become 1 0 0 minus 1 to the power n. Okay, and if I want to write e to the power sigma 3, so it will become e 0 0 e to the power minus 1. Okay, correct? So this I want to write using our spectral decomposition method. So we already know the formula. Just to make you understand, we already know the formula, and we will write this matrix in the form of spectral decomposition. So ऐसे ही करते हैं, जब भी कोई टफ चीज सीखते हैं तो पहले कोई आसान सा क्वेश्चन लेके उसके ऊपर अप्लाई कर लेते हैं. So suppose I have to use spectral decomposition method for this. So how it will go? That is my question. So what will be the first step? So first step will be the calculation of eigenvalues. Okay, the calculation of eigenvalues will be the first step. Correct? So let us write the eigenvalues of this. What will be the eigenvalues? जल्दी से बताना.
1 and minus 1.
So if you calculate the eigenvalues, it will be 1 and minus 1. Okay, and then what is the eigenvector for this?
1 0 and 0 1.
Yes,
So 1 0 and 0 1.
you have calculated.
Sir, yes.
इतना fast?
It's a diagonal matrix, so you can write. And also it is diagonal matrix, na sir?
So this, it is a diagonal matrix. So eigenvectors I will write. Eigenvectors corresponding to 1 will be what?
1 0 sir.
It will be 1 0, and eigenvector corresponding to lambda is equal to minus 1 will be 0 1. Okay, so you have to calculate actually, and you can see from here also. Okay, so now using the spectral decomposition method, we know that f of this a, here f is sigma 3, f of sigma 3 will be equal to E of sigma 3 into inner product. So suppose this one is x1 and this one is x2. So here we will have x1, yes, and plus. So here we have e to the power, suppose this is lambda 1, this is lambda 2. So here we will have lambda 1 and plus e to the power lambda 2 and then inner product of the second vector x2. Okay, it will be like this. So now let us write the final form. So our function here is e to the power sigma 3 and that will be equal to e to the power 1 and x1 का inner product लिखना है, तो we will write it as 1 0 and 1 0. Please see this. In this notation you are aware in quantum mechanics also use the same notation. So this matrix is a 2 cross 2 matrix. So this is
E into 1.
The value.
So
No, notation is wrong because here I will write 1 0 and then 1 0 because this has to be 2 cross 1 and this has to be 1 cross 2, then it will come 2 cross 2. Okay, and plus here it will become e to the power minus 1 and then 0 1 and 0 1 0 1 and 0 1 here. Okay, so now when you multiply, what you are going to get is this same e 0 0 e to the power minus 1. You already knew the answer because it is a diagonal matrix, otherwise you will have to do it. So this was just to tell you that this concept is working. So please see all the steps. We have a matrix capital M is equal to 1 1 1 1 1 1 1 1 1. This is a 3 cross 3 matrix. Okay, so part A, eigenvalues. So eigenvalues you calculate quickly, you will get 3 0 0. Please see this. If you have a matrix with all elements equal to 1, so it is a n cross n matrix. So eigenvalue is given by n and all other eigenvalues will be 0. This is a property that you can use. Okay, so eigenvalues will be 3 0 0. Calculate quickly. Can you see that eigenvalues is this? We have to prove that as a B part that e to the power m is equal to I plus e to the power 3 minus 1 by 3 into m. This we have to prove. So eigenvalues calculated quickly. Are you getting the same? So this is e to the power m is equal to this. We have to prove using this. So please see, e to the power m, I have told you, is I plus m by 1 factorial plus m square by 2 factorial plus dash dash dash. This is correct? This you know? And what are the values of this? M cube by 3 factorial plus dash dash dash. So what is the value of m square if you calculate? Of m square.
3m.
So if you multiply, you will get m square is equal to 3m. Because you know elements add हो जाएंगे ना, 1 plus 1 plus 1. So 3 will be everywhere, you will take 3 common. And now if you multiply m cube, then what you will get? 3 square m. Because m square will again become 3m, yes? Correct? So you will get e to the power m is equal to I plus m by 1 factorial plus m square is 3m by 2 factorial plus 3 square m by 3 factorial plus dash dash dash. Now you can see that you need a series of e to the power 3. So what will be e to the power 3? It will be 1 plus 3 upon 1 factorial plus 3 square upon 2 factorial plus dash dash dash. And you can see there is a chance of getting this. So I plus m, if I take m common, and you see here we have 2 factorial, and but you need square. So how you will manage that? So you have 1 plus, here you see you need 1 plus 3 upon 1 factorial, then 3 square upon 2 factorial. So what you can do is you can just take 3 common, and 3 multiplication, 3 multiply, just wait, I will write in steps, don't worry. So m taken common, it will become 1 plus 3 by 2 factorial plus 3 square by 3 factorial plus dash dash dash. Now you can see you can get e to the power 3 here. So you want all these terms, 1 plus 3 upon 1 factorial, like that. Okay. So what I will do, I will just divide it by 3 and multiply it by 3. So I will get 3 here, then 3 square, then 3 cube, like that. But I want 1 also. So I will just write here 1 plus, and finally I will write 1 minus. Now I will get identity matrix plus m by 3. This all will give you e to the power 3 minus 1, which is your answer. So this is very nice question, just to make you understand. So यहाँ पे मैंने spectral decomposition use करने के बजाय I have told you the formula of sine and exponential, all that I have told you. So I have used that instead of spectral decomposition. Correct?
Sir,
Hmm.
So this basic question that how the m squared become 3m, sir? I can't.
So how you will calculate m square if you are saying basic question?
Multiplication.
So multiply, na? You don't know
Okay.
multiplication of two matrices. 1 1 1 1 1 1 1 1 1 and then again 1 1 1 1 1 1 1 1 1. So when you will multiply, so it will become 1 plus 1 plus 1. So it will become 3 3 3 3 3 3 3 3 3.
Yes, sorry.
So take 3 common and it will become 3m. Okay. Is this okay?
Yes.
So once you should have done it, otherwise you will have no idea that how this will come. Okay, but now if you have done it once, then you know that functions can be written. And what about eigenvectors if I want to calculate for the same matrix? So can I raise this? Please see. Tell me quickly that किसी ने normal method से निकाला eigenvalues 300?
Yes, sir.
Yes, sir.
Okay. So how to get the eigenvector corresponding to lambda is equal to 3? So it will be m minus lambda I into x is equal to 0. This is the method. So you put lambda is equal to 3, what you will get? 1 minus 3 is minus 2. Correct? And then x1, x2, x3 is equal to 0. So if you want to do little elementary transformation, you can do just to make a few elements is equal to 0. So suppose, or if you don't want, you can directly write minus 2x1 plus x2 plus x3 is equal to 0, and x1 minus 2x2 plus x3 is equal to 0, and x1 plus x2 minus 2x3 is equal to 0. So these are the three equations which you got. So the method is that you remove same quantities from the two equations. For example, you remove x3 from this also and x3 from this also. Or you can use that method also जो हम लोग class 10th में पढ़ते ना x upon करके ना, that also can be done. So what are the values? So if I remove x3 from this, what I will get? Minus 2x1 minus x1. So it will be minus 3x1 and plus 3x2 is equal to 0. So it will become x1 minus x2 is equal to 0. So this is the equation, and if you just multiply it by 2, and then what you will get? 2x1 minus 4x2 plus 2x3 is equal to 0. These two equations are same, and you add them. So what you will get? 3x1 minus 3x2.
3x2.
So same equation, no? x1 minus x2 is equal to 0. Correct? So these two equations are same. And what about the third equation? So these removing x3 from there gives you the same two equations. So x1 is equal to x2, that is for sure. And then what is x3?
x1 is equal to x2 is equal to x3.
So x3 is 2x2 minus x1. So that is equal to x2. So now if I want to write it, it will become 1, 1, 1. Yes? For lambda is equal to 3. This will become the eigenvector corresponding to lambda is equal to 3. So similarly, you will write for lambda is equal to 0. And again, you will write for lambda is equal to 0. So those three will become your eigenvectors, corresponding eigenvectors. So this was a question in which we calculated. So those two, do it 0, 0. I mean, try to write it. So ये भी कर लेते हैं जल्दी से. This is important. So suppose I want to write it for 0, then what will happen? It will be 1, 1, 1, 1, 1, 1, 1, 1, 1 into some x1, x2, x3, and this is equal to 0. Now by elementary transformation, suppose I subtract this from this and also this from this. That means I can change R2 change to R2 minus R1 and R3 change to R3 minus R1. Suppose I do that. So what will happen? It will be only 1, 1, 1, 0, 0, 0, 0, 0, 0, and then x1, x2, x3 is equal to 0, correct? So I will have only one equation, x1 plus x2 plus x3 is equal to 0. And you know how to write the eigenvectors for this. So if x1 is k1, x2 is k2, then x3 will be what? Minus k1 minus k2, correct? So one eigenvector corresponding to 0 I can write 1, 0 and minus 1, linearly independent. And another eigenvector I will write, I will take this 0 and this 1 just to make it linearly independent. So 0, 1, and then what you will get here? Minus 1. And see, these are orthogonals also. These are perpendicular because this is a symmetric matrix. So suppose this is x1, this is x2, this is x3. So if you see x1 dot x2, that is 0, x1 dot x3 is also 0, and dot product of this is also 0, x2 dot x3 is also 0. So these are eigenvalues and eigenvectors, correct? If there is any doubt, you can ask. These questions are just based on your previous year questions. So I can erase this, or anybody wants to ask anything?
Sir,
Hmm.
sir, I think I am not getting x2 dot x3 for. Sir, sir, it is 0, 1 minus 1 and 1, 0 minus 1. So when we are doing the dot
Where is
product,
1, 0, minus 1? This?
sir, x3 you have written as 0, 1 minus 1 and x2 1, 0 minus 1. When we do the dot product, it is
Hmm.
0, 0, and there is a +1 remaining. is it?
1 1 0 and -1 0 हो गया
So
0
x2 and x3. Yes.
x2 0
Yes.
0 and 1. So
So 1 is remaining.
so I should write it so that it becomes 0. I should write 1 because this should be orthogonal also, no? So just wait. I will write this so that it becomes 0. So there is a method I can calculate. Suppose this is x1, x2 and x3. No, a, b, c. This suppose a, b and c. So dot products with both should become 0. So one equation will give me a plus b plus c is equal to 0 with this, and with this will give me a plus 0b minus c is equal to 0. Correct?
Yes, sir.
So a will become equal to c. So I should write a is equal to c. So this is c. And what is b? B is equal to minus a minus c. That means minus 2c. Huh? So this is minus 2c. Now take c is equal to 1. So it will become 1 minus 2 and 1. So this is better. Always take this. Now check.
Yes, sir. It's coming.
Okay. So because I have used the property, na, I have taken dot products with this also and both should be equal to. So for third, see, for first no confusion. For second one, because this is degenerate eigenvalue. So if you want to calculate the next one, just use this condition. Because for similar matrix, for this matrix is A transpose is equal to A, so its eigenvalues, they are eigenvectors, they are orthogonal. Now it is okay?
Yes, sir.
So I can erase this. This was very important part. Properties, if you do any mistake, properties से पता चल जाता है और आप तुरंत correct कर सकते हो. So you should always keep applying the properties. So there is a matrix A which is A 0 0 0 0 A 0 A 0. This is a matrix, and then there is a matrix e to the power a. Okay, this is also a matrix. So question A is, what is this matrix? And can you tell how to write this matrix? What is A transpose of this?
To diagonalize, sir.
What? So this is a symmetric matrix. So let me do this part B. Part A is, what is lambda 1, lambda 2, lambda 3? Tell me. So that will be A minus lambda minus lambda 0 0 a 0 0 a. This we will put equal to 0, the determinant value. So what I will get, a minus lambda square minus a square is equal to 0, because these terms will not contribute, correct? So what will be the value? A lambda square minus lambda cube minus a square is equal to 0. So if you write it, lambda cube minus a lambda square plus a square is equal to 0. So this is the cubic equation, solution of which will give you the eigenvalues.
लैम्डा स्क्वायर माइनस स्क्वायर वो ब्रैकेट में रहेगा ना?
Yes,
Where?
sir.
कहाँ पे?
लैम्डा स्क्वायर
Yes,
माइनस
sir. Yes,
स्क्वायर
sir.
वो ब्रैकेट में रहेगा
Oh
ना?
yes. This
Simple mistake.
should be.
Mistake होगा.
तभी तो मैंने कहा सॉल्व ही नहीं होगी इक्वेशन. So it will become a. पहली बात तो इन दोनों का प्रोडक्ट 0 है, तो एक तो लैम्डा इज इक्वल टू a ही हो गया.
यस सर, दूसरा वाला भी
And-
एक कॉमा माइनस
और दूसरा भी a हो गया और एक माइनस
है.
So this question is done and the sum should be a. So sum should be a. Okay, it is correct. And one question may be asked, let me tell you, about, जल्दी से मुझे वो फॉर्म जो मैं लिख रहा था, एक्चुअली देयर वाज अ पर्पस बिहाइंड दैट, जल्दी से वो बताना. लैम्डा क्यूब के फॉर्म में.
lambda cube minus a lambda square minus lambda a square plus a cube equal to 0.
So because of Cayley-Hamilton theorem, it will follow its own equation. So a cube minus a square minus a square plus I a cube is equal to 0. And I should be I3 actually, unit vector 3 cross 3, because it is a 3 cross 3 matrix. So this is also correct. So suppose given which one of the following is correct, ऐसी questions लिखी हो, so if you have no idea of Cayley-Hamilton theorem, you can't write. Are you understanding my point? So this is another part, the part C, where this has to be written. This was the eigenvalue part which we have done. And can we quickly calculate the eigenvectors also? What will be they?
So 1 0 0 0 1 1
और
and 0
प्लस
1
ए
1.
लैम्डा स्क्वायर होगा ये.
Sorry?
प्लस ए लैम्डा स्क्वायर होगा ना?
प्लस मैंने तो डायरेक्ट लिख दिया, जिस किसी ने बोला.
जी
Plus?
नहीं, वो माइनस नहीं, प्लस होगा. ए लैम्डा स्क्वायर वो दोनों प्लस है ना, यहाँ पे इक्वेशन में.
So symmetric matrix, मैं ये कह रहा था कि if I calculate the eigenvectors, so see this from this matrix, the eigenvectors, I can write x1 is equal to 1 0 0 and x2 is equal to 0 0 1 and x3 is equal to 0 1 0. You can check also, you can calculate also, because all other elements are 0 na, you see the columns. So now if I so that may be a00 also, okay. So it can be divided by a finally, or if I can say it can be normalized. These are normalized eigenvectors. So what will be the value of e to the power a? Tell me.
सर आइगन वेक्टर्स डिफरेंट आ रहे हैं.
Yes, sir.
इसके corresponding निकाला. यहाँ पे क्या आ रहा था? आइगन वेक्टर इज ए ना?
ए माइनस ए.
हाँ, तो आपने किससे corresponding निकाला?
माइनस ए. यस सर.
तो यहाँ पे आ गया 2a. आपका आया है 2a?
Yes, sir.
यस सर.
And then a and then a and 0 0 a 0 0 a. This into x, x1 x2 x3 is equal to 0. यही आ रहा है?
Yes, sir.
Yes, sir.
So first element will give me x1 is equal to 0. Correct? Which is coming let me write it using equations, then I will check. Huh? x1 is equal to 0, 2a x1 plus ये हो गया. Second one is 0 x1. Second and third are same, na?
Yes, sir.
So we will subtract this and this will become 0. So only one equation is there. 0 x1 plus ax2 plus ax3 is equal to 0. So that means x2 is equal to minus x3. Just wait करना ये. So what will this become? x1 is 0 and x2 is suppose 1 and this will become minus 1.
Yes, sir.
And what about the next eigenvector corresponding to a?
0 1 1 सर a के लिए आ रहा है.
नहीं
दूसरा
अगर a रखें तो क्या आ रहा है ये बताओ जल्दी से.
0 1 1
0 यहाँ पे माइनस है और यहाँ भी माइनस है. So it will become 0 0 a and 0 0 a. ये आ रहा है ना? So
Yes, sir.
these two equations are same, na? Because this will be gone. I can convert it R3 change to R3 plus R2. So this will also become 0 0 0. So only one equation is there. 0 x1 plus minus ax2 plus ax3 is equal to 0. Okay?
Yes, sir.
So it will become x2 is equal to x3. x2 is equal to x3. And we can write this as x2 and x3 are same. And we can write this as 0. So it will become 0 1 1. And this is degenerate value, na? So one value I can write 1 1 1. But we have to check. Let
So
me
you can take 1 0 0.
Yes, 1 0 0.
1 0.
So it should be orthogonal also. 1 0 0. Can be 1 0 0. So 0 0 and 0. With this 0 1 and 0. And with this 0 0 0. ठीक है. Okay. So these are the values. So we should write it like this. And what are the normalization constants? Root 2 here, root 2 there also, and 1 in the last one. Correct?
Sir?
Hmm.
Sir, for spectral decomposition, it is necessary to normalize the eigenvectors?
Normalize. Actually, the one we did normalization was 1, na?
Yes, sir. The previous one, we did not require it to. The e to the power sigma 3 one.
But their normalization was 1.
Yes, sir. Yes, sir.
So that's why. So these are the eigenvectors, and if I write them in normalized form, it will be 1 by under root 2 here, and 1 by under root 2 here, and 1 here. Now, can we write quickly e to the power? आप लोग जरा multiplication बताते हैं ना? So e to the power a will be now e to the power lambda 1, and suppose this is x1, so x1 and e to the power lambda 2 x2 and e to the power lambda 3 x3. So the first one is a, so e to the power a, and the multiplication of eigenvectors, so that will give, here we should have 3 cross 1, 3 cross 1, which is, यहाँ पे क्या था एक बार बताना, वेक्टर जो था, what was that?
0 1 minus 1.
1 minus 1.
0 1 minus 1.
Yes, sir.
फिर वो
No, sir.
minus
It was
एक
1 0 0.
No,
was minus
it
एक.
was
It
0
was 1
1
0
minus.
0.
Sorry?
1 0 0.
Corresponding to a, I am asking.
Yes, sir.
पहले माइनस ए लिख देता हूँ. First of all, minus a. Then tell.
1 upon root 2, 0 1 minus 1.
0 1 minus 1 and 1 by root 2. And here what is that?
The same thing.
0 1 minus 1 1 by root 2. Okay? And plus e to the power a. Now 1 by root 2, 0 1 1. नहीं, 0 1 1 and 0 1 1. Okay? And the third one, 1 0 0 1 0 0. So this will become a 3 cross 3 matrix, this will become a 3 cross 3 matrix, this will become a 3 cross 3 matrix, and then you will multiply them. Each element will be multiplied by this because, and then added. समझ आ रहा है ना सबको? This will become a 3 cross 3 matrix because this is 3 cross 1 and this is 1 cross 3. So result is 3 cross 3 matrix. And similarly this and this will also become a 3 cross 3 matrix. And then to every element here e to the power minus a will be multiplied. To every element here e to the power a will be multiplied, and similarly there e to the power a will be multiplied. So can you do it quickly and tell me what will come?
सर ए की जगह ई की पावर ए आ जाएगा इसमें मैट्रिक्स के अंदर।
इसमें
यस सर, ई की पावर ए आ जाएगा मैट्रिक्स के अंदर, जहाँ पे भी ए है, एक्सपोनेंशियल पावर ए।
ऐसा कैसे?
e to the power a 0 0 0 cos hyperbolic a sin hyperbolic a and then 0 minus sin hyperbolic
नहीं,
a
जो
cos.
अभी पहले बता रहे थे वो आप ये कैसे बता रहे हो भाई? बताना जरा।
सर मल्टीप्लाई करके।
अरे नहीं, जो कह रहे हो e to the power a आ जाएगा a में।
सर मल्टीप्लाई करने के बाद में आ रहा मतलब।
यार ये कोई डायगोनल मैट्रिक्स हो ना कि बस e to the power a हो जाएगा। दिस इज नॉट अ डायगोनल मैट्रिक्स।
Sir,
हम्म
to calculate e to the power a, we also can diagonalize the matrix A and then apply e to the power a. No?
then you again there also you will have to write p matrix, p inverse matrix। वो भी कोई आसान नहीं है ना, उसमें भी तो ये सारी चीज भाई
हाँ
देखो।
सर।
उसमें भी जैसे तुम a लिखते हो तो that becomes p d p inverse। so when you write e to the power a you will have p e to the power d p inverse। so इतना तो फिर भी करना पड़ेगा। इसीलिए एग्जाम में हमेशा इतना उनको पता है कि बहुत ज्यादा कैलकुलेशन है तो वो 2x2 रखते हैं, या इस टाइप की मैट्रिक्स है तो कुछ और पूछ लिया। फॉर एग्जांपल a a e to the power minus a है, so eigen values will be e to the power a, e to the power a and e to the power minus a।
But sir, we also know that after diagonalization, the matrix will be the diagonal value will be the eigen values of the matrix. So sir, then also we have to calculate the whole. Yeah, we can also.
So if suppose that matrix is diagonalizable, then only that answer is correct। Otherwise in some cases that will not be diagonalized। I told you na, diagonalization is a special case of similarity transformation।
Yes, sir.
So you all do this and then I will discuss it further। Okay, thank you।